In this video, you will learn about standard form of quadratic functions. On this slide, we see real-world examples of parabolas, which is what our graphs of quadratics look like. Essentially, if we look at every single one of these graphs, we can see some sort of arch, like I'm highlighting, and that's what we would call a parabola. On this next slide, we see more real-world examples of a parabola. Yes, in some examples, like the one I'm demonstrating right now, they open upwards, but it's still the same general process. The graph of a quadratic function is called a parabola. And essentially what that means is it's some sort of U-shaped, either opening up or opening downwards. And within each parabola, there is both a vertex and an axis of symmetry. Now the vertex is this bottommost point, which we have on either the bottom or the topmost point of our graph. So you're drawing in these points and the arrows pointing to them. The axis of symmetry is the vertical line that is the line of reflection. So if I were to fold this in half, it would reflect onto itself. So you're drawing in the dashed line and the arrows to both of those. Now, a parabola has a minimum value if the graph opens upwards. So in this case, this point right here at the bottom is what we would consider to be our minimum value because it's at the bottom. In the other graph, we have a highest possible value, so it's what we would consider to be a maximum. The range is the set of outputs or y values of the ordered pairs. Now, if I look at something like the first example, the range is y is greater than or equal to -2 because our smallest y value is -2 and it's everything above this. For the range for the second one, the range is y is less than or equal to 4 because the highest possible y value is 4 and it's everything below this. Now, the first types of questions we're going to see related to this are identifying parts of the graph. The vertex is the highest or lowest most point. So our vertex would be this bottommost point. So if we wanted to fill in the question, the vertex would be the ordered pair -1, 3. The axis of symmetry is the vertical line that goes through the vertex. So we want to draw in our axis of symmetry. Now the axis of symmetry is always going to be the form of x equals and some number. So in this case, x equals -1. Now for the point corresponding to P, to get from P to the axis of symmetry, we have to move over 2 boxes. So if I move over 2 boxes to the other side, this gives me the point on the other side. Now this point has the coordinate of 0, 4. For Q, to move from Q to the axis of symmetry, I have to move over 1, 2, 3, 4 boxes. So if I move over 4 boxes on the other side, this is my corresponding point. So the ordered pair is -3, 7. The last part of this question is the range. In this case, since we have a minimum value, all the y values, the smallest y value is 3, and it's everything that is sequentially bigger than that. So your range is y is greater than or equal to 3. For our next example, the vertex is the highest or lowest most point of the graph. So the vertex is this highest most point, and the ordered pair is -1, -4. The axis of symmetry is the line of reflection through the vertex. So I can draw in the axis of symmetry, and the equation would be x equals -1. Now the point corresponding to P, to get from P to the axis of symmetry, I have to move over 1. So if I move over 1 on the other side, I get my corresponding point of -2, -6. For the corresponding point to Q, to get from Q to the axis of symmetry, I move over 2. So if I move over 2 on the other side, I find the corresponding point, which has a coordinate of 1, -12. The last thing we have to do now is identify the range. So the range is all the possible y values. Now the y values start at -4 and are everything less than that. So this means that our range is y is less than or equal to -4.